Hey guys, welcome to Unit 7, Lesson 4. Our topic today is the special angles. So I want you to pause the video and try the warm-up. Make sure to draw pictures when you're working on your warm-up. So the warm-up says a monument stands on level ground 325 feet from point A. So a monuments are usually straight, right? They can be drawn straight. And stands on a level ground 325 feet from point A. So I have this point A and this distance is 325 feet. If the measure of the angle of elevation, okay, going back to geometry, angle of elevation means at A, if you're looking up, like if you were standing and you're looking up, so that's your angle of elevation, which is 27 degrees. Find to the nearest foot the height of the monument. So height is what? This. So again, you know a side, you know one angle, and you want to find side. So you will be using trig, right? If you know two sides and you wanted to find the third, that's when you use the Pythagorean theorem. But anytime an angle and a side are involved, you want to find the third side or second side, you always use thus trig ratios. So let's write down our SOHCAHTOA. I like to write it as ratio so that we know what it means. So sine, again, this is sine, cosine, tangent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Right, we've been discussing this in the past lesson, so I'm hoping all of you are pretty comfortable with it. So anyways, let's look at this angle. Based off this angle, what side is this? This is opposite, right? And what is this? This is adjacent. So which trig function will I be using here? I will be using tangent. So tangent of the angle. Cannot write just tangent by itself. Some of you just would write tangent. Tangent theta, tangent angle, whatever that angle is, you must write that. So 27 equals x over 325. All you have to do is cross multiply. Make sure your mode is in degrees. So x is equal to approximately 166. That's feet. Okay, let's try number 2. So it says if cotangent of theta is this ratio. What's the ratio for cotangent? Again, going back to your SOHCAHTOA, I'm going to rewrite it here. Cotangent is inverse of tangent, or reciprocal of tangent, I would say. So if tangent is opposite over adjacent, cotangent is adjacent over opposite. So this is adjacent, this is opposite. And it's negative, right? So let's draw our quadrants, our coordinate plane. And cotangent is negative in the second and fourth quadrant. Now, where is, this is secant. Secant is greater than 0 means it's positive. Secant is reciprocal of cosine. So secant is positive in the first and the fourth quadrant. So our triangle or our reference angle is triangle is going to be in the fourth quadrant. So I'm just going to draw that. So this is what my reference triangle looks like. That's going to be theta, and adjacent. This side is adjacent to theta. So this is what? -4 rad 33. And your opposite is 33. Right? And now I want to find what? Sine of theta. What's the ratio for sine opposite? I already know my opposite, my hypotenuse. I don't know my hypotenuse. So I'm going to do is what? My Pythagorean theorem. So a square plus b square equals c square. So my a square, my sides are, it doesn't matter which one you pick to what? Plus 33 square equals c square. So I get 1089. Oh, 528, not 1089 is the other one. You can put that in the calculator. Make sure this is going to be a positive number. So 528 plus 1089 equals c square. C square equals 1617. And I'm left with, take the square root, and now you must simplify it. So this would be what? 7 rad 33. So your two factors were 49 times. If you're confused how to simplify radicals, the largest perfect square that goes into 617 is 49. So square root of 49 is 7 and rad 33, right? So sine theta is opposite, which is what? 33 over 7 rad 33. And we're in the fourth quadrant, so make sure our sign is going to be what? Negative, right? So if I want to simplify, I'll just rationalize, multiply, and divide by rad 33. So what do I get? I get 33 rad 33. It's negative over 7 times 33. The 33's cancel out, and my final answer is negative rad 33 over 7. So that is what the ratio for sine theta is, right? So I'm hoping we're all very comfortable doing these questions. Because special angles, there are two special right triangles. You have seen these again in the past, so let's quickly review them. They're 30, 60, 90, which means that one angle is 90, the other is 30, and the other is 60, right? And their ratios, we're going to be talking about the sides opposite to each one, the length, right? And their relationship. And the 45, 45, 90, because these will help us to fill out our values for our sine, cosine, and tangent. So I'm going to quickly review this, where these comes from, in case you forget. If I had an equilateral triangle, let's see, right? And my equilateral triangle is, means each angle is 30, 60, 60, 60, right? So what if I pick side 2? Let's say the length of each side is 2. So now if I drop a perpendicular, would you agree that now these sides will be 1 and 1? Just this part would be 1, this part would be 1, right? Because it's perpendicular. Bisect, it bisects or divides that line segment into 2 equal halves. And also now this angle is 30. So did I get each one a 30, 60, 90 triangle? This looks funny. 30, 60 degrees. These are in degrees. Okay. So already you know this is 2, this is 1. Can you not find, using your your Pythagorean theorem, this side? And it happens to be, if you did that, a squared plus b squared equals c squared. You knew your c, that's your a, and it would be rad 3. So that's how you can come up with these sides. And look here. Across from 60 is rad 3. Across from 60 is rad 3. Then across from 30 is 1. Across from 30 is 1. And your hypotenuse is always double the short leg, or so, which is 2. Your short leg is across from your smaller angle. So I hope we understand that. All you have to know is just know this triangle. You don't have to know this, how we derived it. I just feel like it's good to know where it comes from. Similarly, this one comes from a square. If I had a square, and if you agree, and each angle is what? 90 degrees, right? If I draw a diagonal, the beauty of a square is that the diagonal bisects that angle. So this would be 45 and this would be 45 in a square with length 1. So if I did my Pythagorean theorem, I'll end up with my diagonal to be rad 2. And look at this. This is the same thing. Across from 45 you have lengths 1 and your hypotenuse is rad 2. Okay, so the best method for working with these triangles is to work directly with the triangles themselves. By remembering the relationships in these triangles, you can find any of the 6 trigonometric functions in any situations. So when I say the relationship, you can basically do sine of 30. So if I did sine of 30, what is the ratio for sine? Opposite over hypotenuse. So its opposite is 1 over 2. Similarly, I'm going to write all those. Cosine of 30 is what? adjacent over hypotenuse, so rad3 over 2, and tangent of 30 is what? Opposite over adjacent. And I'm going to rationalize it. So this would be rad3 over 3. Either you can come up with these values, these are called the exact values for these angles from these triangles, or I'm going to teach you a trick right here. But then again, you have to remember the trick. So the trick is you write 1, 2, 3, and then backwards. 3, 2, 1. And divide each of them by 2. This is only for sine and cosine. These are your special angles, 30, 45, and 60. So, and take the square root of the numerator. So this is basically 1/2 because square root of 1 is 1. So that's it. So those are your exact values for your special angles 30, 45, and 60. And this is how you remember them. You have to have them memorized, guys. So either I would highly recommend drawing this table, practicing it multiple times. So now how do we do tangent? Tangent is going back to your unit circle, sine over cosine. If you've forgotten, the ratio for tangent theta is sine over cosine. So I'm literally going to take this over this. If I simplify it, and we did that up there also, tangent 30 was what? It was 1 over rad3, right? Then we rationalized it, and then we got rad3 over 3. So think about it. Sine divided by cosine, same thing divided by itself is just 1. So tangent of 45 is 1. Now tangent of 60 is actually, again, divide this by this and keep change flip. So let me show it to you. You don't have to do it every time. Once you get into a pattern, like into a habit of doing it, you'll see a pattern, and then it'll be good for you. I'm just gonna over 1/2, do keep change flip. It's rad3 over 2 times 2 over 1. The 2's cancel, so you're left with just rad3. So again, this is rad3 over 3, tangent 30, tangent 45 is 1, and tangent 60 is rad3. You can either refer to those triangles if you can draw the triangles and figure it from there, or just work them out. Okay, so quadrantal angles. What are quadrantal angles? Whenever we talk about quadrants, I've always said this is the first quadrant, this is second, third, fourth, right? Quadrantal angles are angles that fall on the quadrants. Like, what is this angle? 0 degrees, 90, 180. If I'm going in counterclockwise direction, 270. And if I'm going in clockwise direction, this is still 0 degrees, or 360 you can say. And this would be negative 90, negative 180, and negative 270 degrees. And this would be negative 360 degrees, right? So remember, these are our quadrantal angles, and anytime we're working with the quadrantal angles, I would say use the calculator. You can either remember them, you can have them memorized, but anytime you have a quadrantal angle, just put that into the calculator and you will get those. So we can write these 0, 90, 180, 270, and 360, and so on are all my quadrantal angles, right? So going back to your unit circle, what's a unit circle? A circle with a radius of 1. My pictures are really sloppy. I'm just going to try again. This was not that. So let's do this. Lines should be straight. I'm trying. Okay, yep, this is better. So what's a unit circle? I'm going to draw it here. A unit circle is a circle with a radius 1, right? So if I had this circle here, I'm just going to sketch it in a dotted line. Would you agree this point would be 1, 0? This would be what? 0, 1. This is what? Negative 1, 0, and 0, negative 1. And in a unit circle, any point xy is what? x is your cosine and y is sine. So just in reference to that, so cosine of 0 would be what? Your x coordinate. So cosine 0 would be what? 1. Sine 0 would be 0. So this is your x. Remember, your x, I'm going to underline this. Your x is your cosine and your y is your sine. So if I said, so I'm just going to write out all of these. Cosine of 90 degrees is 0. Sine of 90 is, again, that's the y coordinate. It is 1. Every x coordinate is your cosine value. Every y coordinate is your sine value. So let's finish up the rest of them. Cosine of 180 is -1. Sine of 180 is 0. I don't know if you've noticed, but sine is going to be 0 on here and cosine is 0 at 90 and 270 and so on. It's going to be going like that in circles, and you can keep going on. Sine 180, and then I'm left with, I'll just change colors. Cosine of 270 is degrees 0, and then sine of 270 degrees is -1. This is 0. Okay, and then we come back to here, which is 360. So I'm going to be sine and cosine. Cosine would be 1 and sine of 360 would be 0, and so on. So these are your exact values. You cannot give me decimal answers. You cannot do that. So please try not to put them in the calculator. That's why you have to have them memorized. Either draw the triangles or have them memorized as the picture. So again, I want you to pause, not look at the previous page, and fill this table out. Do the trick, whatever you want to do, and try it. So I filled up my special angles. You have to remember these, guys. And let's get started with the other. What I want to do in the bottom table is I want to do the same thing for the reciprocal functions of sine, cosine, and tangent. So the reciprocal of sine is cosecant, which we write it as C as C. Cosine is secant, and tangent is cotangent. And we're going to find the exact values for the same special angles, 30, 45, and 60. So again, you can either go back to your triangles, or I will just take these values and I will flip them. So this would be what? 2/1. This would be 2/2. 2/2. Let me get some color. Rationalize it, and this would be just 2/2/2. So this is just √2. I'm just going to write it here, √2. Then I have 60, which would be 2/3. Rationalize it. So what do I get? 2/3/3, right? And I don't know if you've noticed, but look at sine and cosine. Sine going from left to right, it's these values, and it's the same values for cosine in the other way, because sine and cosine are actually complementary angles. So let's fill this out. So this would be what? 2/3/2. This would be again √2. Sine of cosine of 45 is the same value. So similarly, cosecant and secant will have the same value too. And this is just going to be 2. And now, again, tangent, very easy. Flip it. So if I flip, this is going to be 3/3. Rationalize it, which would be just 3/3/3. The 3's cancel out, so it is √3. I know it's initial a little bit work, but once you get a hang of it, that's why I said draw a few, take a paper, draw the table, fold it, and do it 3 to 4 times in order to be successful with it. This is 1, and this is gonna be √3/3. Again, how did I get that? This was √3/1. I flipped it, So it was 1 over rad 3. Rationalize it, so it's rad 3 over 3, right? That's what we got. So this is how you do it. Now why do we need these values? We need these values to solve questions like these. I'll start with the first. Practice problem number 1. So it says the value of sine 60 and cosine 60. Again, you cannot put these in the calculator because it's asking you for the exact values. When you put it in the calculator, those decimals are not exact values, right? You'll have to round them at a certain point. So we need the exact values. So either you can flip over to the last page, or I would say practice these and try to memorize them. So sine of 60 is rad 3 over 2. That's what you do. Just substitute the right value, the exact value, and cosine 60 is 1/2. You really cannot cancel anything here, so your final answer is rad 3 over 4. I want to do number 3 and 4 also. So number 3, it's 3. What's cosecant of 60? It's 2 rad 3 over 3 minus cotangent of 30 is rad 3, and then sine of 90. Again, you can have them memorized, or it's a quadrantal angle, right? 0, 90, 180, 270. These are all quadrantal angles. You can use, for these you can use your calculator or go back to your unit circle. So 90 is here, the point here is 0, 1. So sine is your y value. What's sine of 90? It is 1. That's how you can remember it, or just use the calculator. Now simplify whatever you can. The 3 in the denominator gets cancelled with the 3 in the numerator, so you're left with 2 rad 3 minus rad 3. Now look at this. Your radicands are the same. So what's in here? It's a 1, right? -1. So 2 minus 1 is 1. Rad 3 or rad 3 is just fine. It's understood there's a 1 here. It can't be a 0. Otherwise, the whole number would be 0, right? So with the numbers, or where the angles are in radians, what do? You can actually convert them. That's what you'll have to do. So I've said that in the past also. If you're converting radians to degrees, either multiply by 180 over pi, or just substitute pi with 180. So what is 180 divided by 3? It is 60. So I'm going to write that down again. 2 cosine 60 degrees, and tangent similarly. 180 divided by 6 is 30 degrees. So what is cosine of 60? Cosine of 60 is 1/2, and tangent of 30 is rad 3 over 3. Let's simplify that. The 2's cancel out, and what am I left with? Rad 3 over 3. So I want you to finish the remaining questions and the homework. Good luck, guys.